secondary instrument. So examples are voltmeter, a glass thermometer, and a pressure gauge. The next one is the secondary type of measuring instruments has been classified in the following categories. So secondary instruments are again classified into different categories. So next, the very first one is the indicating instruments. So as its name implies, it indicates something. Okay, so indicating instruments are those which indicate the instantaneous value of the variables being measured at the time at which it is being measured. So what it does, it indicates the value of the variables or a measurement which is being measured. Suppose we are measuring a temperature of milk in a pasteurizer. We have inserted one sensor or or any kind of thermometer in a line, and we are measuring that temperature continuously. This instrument, this indicating instrument, continuously shows the temperature of the milk at that particular time. What will be after 10 seconds, what will be before 10 seconds, what will be the current status of the instrument, it will show. It will indicate something. It will indicate the value of the any temperature of milk, pressure of the pressure in the pipe. It will show. Their indications are given by pointers moving over calibrated dials or scales. Example, ammeter, voltmeter, and wattmeter. So these are the measuring devices by which we come to know what is the state of the current, volt, and power. So this movement of pointer or the deflection is not constant but depends on the quantity measured. So the deflection is not depend upon the any kind of constant, but it depends upon the quantity it measures. Quantities, if you are adding weight on a weighing balance continuously, it will show the value accordingly. Okay, so this is not depend upon any kind of constant, depends upon the quantity we are measuring. Next one is the recording instruments. So as name implies, it records the value or data of the measurement system or any kind of measurement or a variable that is being measured. So recording instruments are those which give a continuous record of variations of the measurement variable over a selected period of time. So suppose in 1 hour, what is the change in temperature will be recorded by this recording devices. So at 1 minute this will be temperature, at 2 minutes this will be the temperature, 3 minutes this was the temperature, 4 minutes this was the temperature. Likewise, we will get to know the what was the status of the temperature at that particular time or the instant. Okay, we can set a scale after 5 minutes, 10 minutes, or we can set a scale like after 1 minute, 2 minutes, 3 minutes, likewise, or after 10 minutes, 15, depends upon us. Okay, so it records the temperature or pressure or anything in the real time. It records everything and it stores that information. Okay, and by retrieving that information we can analyze the data. So the moving system of the instrument carries an ink pen which rests tightly on a graph chart. So in pasteurizer there is one recorder in this graph type of recorder. This graph recorder, what it does, it record the temperature of milk. Okay, it records the temperature of milk continuously on a graph. So any deflection in the temperature, it will show accordingly on a graph. There is a graph, circular graph, and there is a pointer which is the ink pointer. Okay, so this graph continuously rotated, and accordingly this pointer deflects whenever there is a deflection in the temperature. The temperature goes up, the graph will also go up, if temperature is get down, it will also mark the change in the temperature accordingly. So this is the graph type recorder. Then there are some digital recorder too. Nowadays we can use this temperature loggers. Okay, these temperature loggers record the temperature, and that data can then again retrieved for the analysis purpose. So normally these recordings will be for one day, and the recorded sheets are kept as a record of variations of the quantity with time. So if we are using this graph sheet, okay, in that case we need to replace that graph sheet every 24 hours. So third one is the first one is the indicating instrument, recording instrument, and one is the integrating instrument. So these are the instruments which will add up the quantity as the time passes, or in other words will give a total account of quantity spent in a given time for a which it is in a connected circuit. It will also measures, indicate, okay, and it will also sum up the quantity or variables that is being measured. So its best example is your electric meter. The electric meter at our home, or the energy meter at home, what it does, the new devices, if you have seen the new electrical measuring meters or devices, it shows you the what is the current electric consumption, okay, what is the consumption up to date, means when the meter get installed, and what is the from that instant what is the total consumption of the energy up to the today's date. Okay, so this is the integrating instrument. It have all the functions like indicating, recording, also it quantifies them also. So it registers amount of electrical energy consumes over a period of time. Okay, and like your water meter also is example of the integrating instrument. It measures, it shows, it indicates and records the quantity that is being measured. So this is called as the integrating instrument. The next one is the manual and automatic instrument. So what are the manual instruments? Manual instruments are those instruments which required some kind of manpower to handle them. Okay, they cannot work themselves, so for that purpose we need some kind of human intervention for measuring the quantity. So manual requires the service of an operator, whereas an automatic instrument the operator is not required. In automatic instrument we don't need an operator to operate the instrument, but in case of manual instrument we need a manual intervention. Like for example, a measurement of rotational speed by a hand operated tachometer, an operator is required to make the contact of the instrument with the rotating shaft. So there are, for example, there are two kind of tachometers. One is a contact tachometer, one is contactless tachometer. In case of contact tachometer, what will happen? You have to tachometer measures the rotational speed. Okay, if you want to measure some kind of rotational speed of some motor or a fan, in that case you have to make a contact of the rotating part with the tip of the tachometer. So you have to hold that tachometer in hand, and you have to push it again against the that revolving part, and then you will come to know the what is the rotational speed of the that fan or a motor. But in case of a non-contact type of tachometer, you don't need to push that tachometer against the rotating part. You just hold it in your hand, or you don't need, or you cannot, or you also don't need to hold that tachometer in your hand. You can automate it. Once you push the button, it will automatically record the speed of the motor or any rotational kind of thing. So in that case, you don't need an operator to push that against a rotating fan or a motor. So this is the manual and automatic instrument. And next one is the self-operated and power-operated instruments. So what is my self-operated? A self-operated instrument does not require any external power source for its operation. So you don't need any kind of power or energy to measure the things. Okay. In such an instrument, the output energy is supplied by the input signal, that is dial indicator or mercury in glass type of thermometers. So basically, in this self-operated instrument, you don't need an extra power or extra source of power to show or to measure or to indicate the quantity that is being measured. Like in case of thermometer, we are not adding some kind of cell or battery to work that thermometer. Okay, we simply dip the bulb of thermometer inside the liquid, and based upon that, that mercury will go up or go down, and it will show some kind of temperature on a calibrated scale. So we are not it drawing out its energy from the input. Okay, it sucks the energy from the water or any kind of liquid, and accordingly it is working. So we are not providing any external power or source to operate or to function that instrument. So thermometer is the best example of the self-operated instrument. And next one is the power operated instrument. In power operated instruments, some auxiliary power source is required for its operation. So this power source may be electricity, compressor, etc. So if a wall is there, and if that wall is of pneumatic or electrically operated, in that case we need to supply some external power or electricity to operate the wall. Okay, so this is the means they need some kind of external power like electromechanical measurement system. Okay, this electromechanical measurement system need some kind of power or electricity to operate. Suppose like we have tachometer of digital tachometer. Okay, in that case, in digital tachometer, we need to provide, or it has a battery, okay, to operate that tachometer, handheld tachometer, digital tachometer, to give the readings of the variable or measurement that is being measured. Okay. But in case of normal tachometer or manual tachometer, we don't need any kind of external power source. Okay. The measurement itself gives the energy or power to the tachometer. This is the difference between self-operated and power-operated instrument. The next one is the self-contained and remote indicating instruments. So what is my self-contained instrument? Self-contained instrument has all the physical elements in one assembly. Example, an analog ammeter or a mercury in glass thermometers. So self-contained means it is a compact device or an instrument which contains all the parts in it. Nothing externally we provided. Okay, we don't provide externally anything. Everything will be there inside a case or some kind of casing, and in that everything will works accordingly. So in glass thermometer, simple example is a glass thermometer. In glass thermometer there is a mercury in the bulb. Okay, there is a calibrated scale on the surface of the thermometer, and okay, that's the simple construction. And this is the self-contained instrument. Nothing is externally worked, or nothing we provide externally. We just dip that bulb inside a liquid or any kind of matter or quantity, and we get the reading accordingly. But in case of remote indicating instrument, it has some primary sensor element and secondary indicating element are located at two different locations linked by transmitting element. So nowadays it is not possible to go on the shop floor in the industry and check the what is happening, what is the temperature, what is the pressure. You don't need to go on the shop floor, okay, or personally or physically check those things. You install your sensors at the instrument, and you can see that results by on your computer screen. Okay, you are sitting in a lab, and you can see uh, all the parameters of your process. So you are remotely located from your instrument. Your sensor is somewhere else, and your indicating devices are somewhere else, and you are operating those system by remotely, not with the not with the exactly on the same location. You will be at some place, and your instrument will be at some place. So there will be some kind of distance. So this is called as the remote indicating instrument. The next one is the contact type and non-contact type instrument. So contact type instrument means which needs contact with the medium for measurement, like your thermometer. We need to make a contact with the quantity that is under measurement. We need to dip that thermometer inside a liquid, and after that only thermometer will gives the exact temperature of the system. So we need to make a contact with the quantity. That is called as a contact type instrument. Or a handheld tachometer requires the touching or contact with the revolving part, then and then it will show the RPM of the motor or the fan. Likewise, these are the contact type instrument. They need contact with the quantity. After then and then only they can show some kind of readings. In non-contact type thermometers, you don't need to make a contact with the quantity being measured. You can remotely access the or measure the reading of the quantities. You will get some kind of values, like your infrared thermometers. You know, all we are using this infrared thermometers in this to measure temperature of your body. Okay, so it is like a gun like structure, and you can measure the temperature from away from the body. So like there are some kind of pyrometer temperature sensors by which we don't need, if suppose we want to measure a temperature like 2000 degree, 3000 degree, 4000 degree, in that case we cannot take a thermometer in our hand and check the exactly temperature of the that liquid or that kind of metal, molten metal. You know, we will get burn ourselves. So in that case there are some kind of optical pyrometers or temperature sensors by which we can measure the temperature from a long distance. We just need to point out our that temperature laser that are laser operated, and we need to point out our instrument to that quantity, and we will get the readings of the temperature or values of the temperature. So these are the contact type and non-contact type instrument. So here you can see that different mechanical, chemical, electrical, sorry, not chemical, mechanical, electrical, electronic instruments for measurement of different quantities. In mechanical instrument, there are like simple vernier calipers, pressure gauges, okay, screws, scales. These are the all mechanical measuring instruments. In electrical, like your clamps, meter, voltmeter, ammeter. These are the electrical measuring instrument. Electronic means oscilloscope, okay, digital voltmeter, ammeter, okay. And this is the non-contact type measure temperature measuring devices like pyrometer. This is analog recorder. This is the graph, okay, and this graph, and there is having some kind of incorporated pointer. So as the temperature goes or down, up down, it will shows on the graph in this pattern, okay. So this is the analog recorder, and this is the mechanical versus digital type of instrument. So this is the analog type of weighing balance. This is the digital weighing balance, okay. These are the different classifications of the instruments. So today we have discussed about the what is the mechanical, electrical and electronic instruments, what is in by absolute and secondary instrument, what are the manual and automatic instruments, what are the analog and digital instrument, what are the self-operated and power operated instruments, and what is the self-contained and remote indicating devices, okay. So thank you.